Hi guys, in this video I'm going to review some properties of parallelograms. So this unit, we looked at a lot of different quadrilaterals, as well as some theorems regarding just polygons in general. So I've already written some notes. There's kind of a lot here, so pause the video, copy down the notes. What I have drawn in each category is what does that item look like? And then what I've written next to it are the properties that it has. So kites have two consecutive congruent sides, so that's what the picture looks like. All kites have perpendicular diagonals and one pair of opposite congruent angles. Trapezoids have one pair of parallel sides. The mid segment is the average of the bases. So if I add those two bases and divide by 2, I get the length of the mid segment. Specifically, an isosceles trapezoid means those two legs are congruent. If that happens, those pairs of base angles are congruent. So the two top base angles and the two bottom base angles are congruent to each other. And then we talked extensively about parallelograms. So parallelograms have two pairs of parallel sides. And then here's the properties. All parallelograms have opposite sides that are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. Within the parallelogram family, we have special kinds of parallelograms, so one of those being rectangles. So rectangles are parallelograms, but they have 4 right angles in addition to that. And all rectangles have congruent diagonals. Another special kind of parallelogram is the rhombus. Rhombus has 4 congruent sides. Always a rhombus will have perpendicular diagonals, and the diagonals bisect opposite angles. And then if it's both a rectangle and a rhombus and it has all those properties, it is a square. For polygons, we did 2 theorems with respect to angles. We did the exterior angle theorem, which was, exterior angle sum theorem, which is that all the angles around the outside of the polygon, no matter what type of polygon it is, will sum to 360. To find the sum of the interior angles, so like we know triangles add to 180, all depending what size our polygon is, we can find that number for whatever kind of polygon by doing n minus 2, where n is the number of sides, times 180. So that first example, we are going to do that. We're going to find the sum of interior angles of a convex 13-gon. So that means there are 13 sides, so my n is 13. So I'm going to do 13 minus 2, and then times 180. So if I do 13 minus 2 times 180, we get 1980 degrees. So total, all the angles in that 13-gon add to 1980. Okay, classify the quadrilateral. Okay, so here's kind of 2 things we want to look at. We want to look at, well, first of all, just make an educated guess. What does it look like? So to me, it looks like maybe it's a rhombus. I know it's not a square because I can definitely tell those are not right angles. So I got to check 2 things. Is it for sure a parallelogram? If it's not, then it can't be a rhombus. And then a rhombus, remember, had this property that the diagonals were perpendicular. So I'm going to use slope to help me determine these things. So from D to C, I'm going to count rise over run. So I got up 1 over 1, 2, 3, 4, 5, 6, 7, 8. So 1/8 is that slope. For A to B, I should have the same thing. Up 1 over 1, 2, 3, 4, 5, 6, 7, 8. Yep, so we got the same thing. But remember, both pairs of opposite sides must be congruent. So I'm going to check D to A. So I go down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So down 6 over 4. I could reduce that to 3 over 2. C to B, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Sorry, I did that one wrong. So down 7 over 4. So I think these are the same. And this one is also down 7 over 4. So we know that this is for sure a parallelogram because those opposite sides have the same slope, meaning they're parallel. So we're going to say parallelogram for sure because opposite sides are parallel. And we knew that because they had the same slopes. Okay, now let's check the rhombus part. So if the diagonals are perpendicular, they'll have opposite reciprocal slopes. So from A to C, we have up 1, 2, 3, 4, 5, 6, 7, 8, and over 4. So up 8 over 4, which is 2. So our slope of AC is 2. Okay, from D to B, so D to B, I'm going to go down 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my slope from D to B, I went down 6 over 12, which reduces to negative 1/2. Those are opposite reciprocals, so this is a rhombus because diagonals are perpendicular. Okay, so it's important that we did that extra step because this is the most specific we can be, and we want to do that when we can. All right, that's it. Thanks for watching.